We are now in 2.5. And if there is another test, which I'm hoping there will be, that way it'll just kind of offset things, although these last test grades were pretty good overall. So it may not really matter if it's a quiz or a test. It might benefit more to be a quiz to kind of help quiz averages. I'm not sure yet. But anyways, but this basically it'll start here and just be whatever we get through for the rest of the semester. So this section is complex zeros. So we're dealing with I again, and the fundamental theorem of algebra. So we have a couple more major theorems here. So the first one is the fundamental theorem of algebra. And so this says a polynomial function of degree n has n complex zeros. So n is just some number of them. And this could be real and non-real. And some zeros may be repeated. So on occasion we have like a double root or a double zero at some number. That is a possibility, but we would want to make sure we comment on that. Basically, whatever the degree is, that's the number of zeros we should have. That's a good rule of thumb. So that's why you have to really pay attention if you have a double zero somewhere or whatever to make sure they add up to have the correct amount. So we also have another theorem, the linear factorization theorem. So this is if f of x is a polynomial function of degree n greater than 0, then f of x has precisely n linear factors, and f of x is equal to a times x minus z times x, or this is z1, x minus z2 times dot 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 times x minus zn, where a is the leading coefficient of f of x, and z1, z2, zn are the complex zeros of f of x. The z sub I are not necessarily, so z sub I is going to be your complex, but anyways, or your imaginary, I guess I should say, are not necessarily distinct numbers. Some may be repeated. All right, and then just a note about these two theorems. Both of these theorems are existence theorems. And by that, we mean that they tell the existence of zeros and linear factors. However, it doesn't tell us how to find them. So basically, that just tells us that they exist, that we have them, but it doesn't tell us how to find them, so we are going to have something else to help us figure out how to find them. Z sub I, yeah. Yeah. like the complex number I. All right, fundamental polynomial connections. In the complex case, the following statements about a what? About a polynomial function f are equivalent if k is a complex number. And what is the standard form of a complex number? A plus bi. Is that right? Now I'm going to see if I can really get y'all to remember. What is I equal to? What is I equal to? What did you say? I. Yeah, if I say what is I, you just say it's I. Okay, the square root of -1 is I, but I is just I. What is I squared? -1, I cubed. I to the 4th. 1. Okay? Remember, I squared is -1, so I squared would be +1. Okay, so remember, it goes I, -1, I, 1. Okay, that's the order that it follows. Okay, I'll write them down in a minute once I'm done with these. I just wanted to see if y'all remembered them. Alright. X equals K is a solution or root of the equation f of x is equal to 0. K is a 0 of the function f. X minus k is a factor of f of x. It's what? I turned the thing down earlier. I think it's just because it was all closed up this weekend and like the air wasn't really on this weekend. It's like all over the place. Huh? I thought you said this could just be the dying school. I was like, what? Like, I don't know how that factors into that, but... Yep. Too hot. I think you might have a fever if that happens. It's like 800 nuggets. Yeah, a large tray is 200. Yeah, I did a catering order for Water's Edge one time when they do their like Love Week thing that they do. And they ordered from us alone 14 large trays, 12 medium trays, 16 small trays. No, all nuggets. There was a gallon of tea per tray. And there was a tray of cookies. I can't remember what size with every order. No, like the tray size. I got there at like 6 o'clock that morning. Started making food. It was like going to like the fire stations and stuff. Yeah. Yeah, they usually say like 8 nuggets per person, so. Oh, and we did fruit trays. At one point, I also did a salad tray one time. That was exciting. Alright, complex conjugate zeros. Suppose that f of x is a polynomial function with real coefficients if a and b, here we go, Logan, are real numbers. I've written that word way too many times in my life, so I abbreviate it when I can. It's also why I do theorem, THM. Too much work. Yeah, we don't have as many therefore things in this class. Yeah, the little triangle thing. I haven't really written in Algebra 2 either, to be honest with you. I think I did a lot in trig. The trig is a lot more like proof kind of stuff. I'm also pretty sure based on the note I got, you have to take the exam during your exam class too. I won't know till all the grades are in, so next Wednesday, hopefully. But you still have to be here for a review either way, so. Let's see, a plus bi is a 0 of f of x. Then its complex conjugate a minus bi is also a 0 of f of x. Okay, so something I want you to notice about this, because this is a common mistake. If you are told that a plus bi is a 0, a minus bi is also a 0. Okay? I don't know, somebody figured it out. So, that is a very common mistake. Okay, when you do problems, it'll say you have the zeros are 3, -4, and 2 minus I. Let's just say that. Okay, last year, basically you just do x plus or minus whatever it is, okay, and multiply everything out, FOIL it. Okay, we're going to do examples. But the biggest thing that I saw them do last year was forget to write that extra factor. Okay, and your answer is like super wrong if you don't have that. So make sure you remember, if you have a factor a plus bi or a minus bi, the other one is a factor as well. Okay. Let's see. Let's see. I have a lot of examples written down, but I don't want to do those yet. I want to get through all the notes and stuff. Also, this is technically a theorem, just FYI. Yeah, tomorrow's December 1st. It's crazy. Alright, a definition. A quadratic expression with real coefficients but no real zeros is irreducible over the reals. I just barely ever wrote the hyphen. I'll do examples in that color. It's like a teal. Alright, factors of polynomials with real coefficients. If you're not counting this line, then 4. If you're counting, or wait, no, 3. If you count this line, 4. And then there's going to be one more note after that, and then it's just examples after that. Huh? All over real numbers, but not over complex numbers. Basically, this is just another way of saying if we require the factors of a polynomial have real coefficients, the factorization can be accomplished with linear factors and irreducible quadratic factors. Basically, you can't reduce it anymore, in short. Every polynomial function with real coefficients can be written as a, some people do COEF, but for coefficient, let's see, can be written as a product of linear factors and irreducible quadratic factors each with real coefficients Man, I must have written really crooked because my paper is straight. Oops. We'll just... Actually, wait. No, just kidding. This is crooked. I think that made it worse. Did that make it worse? Did that make it better? Meh. It helped a little bit. Alright, and then the last note, and then I'll do some examples. Polynomial functions of odd degree. So it's a little strange. Every polynomial function of odd degree with real Logan, you literally said something about a abbreviation for coefficient on my paper. I actually have it written as an abbreviation in this one. With real coefficient has at least one real zero. I've done a bunch of examples in this section last year. Just don't get behind. Last year the people got behind, and then they had a really hard time doing the project. Too far. Wait. Trying to check something because I didn't do something last year. -2. Yeah, okay. All right. So starting with a couple examples here. So number 2, these problems say to write the polynomial in standard form and identify the zeros of the function and the x-intercepts of the graph. So this one is f of x is equal to x plus 2, x minus the square root of 3i, and x plus the square root of 3i. So we need to write it in standard form first, and then we need to find zeros in the x-intercept if there are any. Like, what do you mean? Well, x plus 2 isn't a 0. Yes. So, I mean, we can do that first if you want. So, like, zeros, because it's already in this form. Basically, you just set each of these pieces equal to 0 and solve for x. But just for the sake of less writing and stuff, you don't have to do that. You can just do it in your head, basically. So, zeros are at x is equal to -2. Okay, setting this equal to 0. X is equal to the square root of 3i. Yeah, i's outside. And then you can put the I in front if you want. The book just has it behind, so I just left it. And then this one would be x is equal to negative square root of 3i. So those are your zeros. It'd be like negative I squared root of 3. Actually, hold on a second. These might not be supposed to be written this way. Sorry, I wrote, these aren't supposed to be x equal. These are just supposed to be written. That's my bad. The zeros are just like whatever the numbers are. The x-intercepts we write as x equals. So I got them backwards. So now, any idea what the x-intercepts are? Or are there any, I should say? Yes. We have to write it in standard form. I'll give you a hint. There's only one. X equals -2. Yes, exactly. These are not real. So the only x-intercept we have is this one. If there was also an x out front here, what would the other one be? 0. Okay, x equals 0. Okay, if I didn't have this, would I have any x-intercepts? No. Okay, so only the real terms can give you intercepts. Okay, and if you were to actually graph it on your calculator, you could see that it's not going to cross the axis for these ones. So now we need to write this in standard form. Now, normally when we start foiling to do stuff like this, we go left to right. So we would start with this one and we multiply it by this one. But, do you think that's the smartest option? No. Which one should I do first? These two, because they are a special type. What are they? Okay, so what does that give me over here then? So I'm going to copy this first factor down. So what does this give me? I squared. I times I, okay. And then what is I squared? So x plus 2 times x squared plus 3, and then now FOIL this. What does that give me? Yep, so that would be in standard form. Okay, you shouldn't have any, I don't think, that end up with any i's left, because obviously, from what we said earlier, if you have one of these factors, okay, if one of these is here, you have to have the other one, so they should always be able to cancel. I'm not going to do 4. Okay, but I want to set up the first part of it and make sure we understand what we're looking at, because it's got a mathematical place where there could be some confusion. So, or at least it looked like it did. Let me verify. Yeah, it does. Okay. Okay. So this one, yes, this is a 1. It ended up with a dot above it. Okay, I would still recommend doing these two pieces first. I'm not going to do it at all. I'm just talking through it really quick. Okay, I would still recommend doing these pieces first, but you are going to have to factor each piece through as the safest way to do it to eliminate errors. Okay, so x times all of these pieces, -1 times all of these pieces, -I times all of these pieces, and then simplifying stuff down. And if it works out correctly, which it should, you shouldn't have any i's left in the problem. But if you do, keep in mind that because standard form i's go to the back of the problem. So you'd want to get it in the a plus bi form if you have an I left over. Okay, but I'm not going to do another one of those. Just really quick, what would the zeros be? Yep. Okay, so just remember you set each piece equal to 0 and solve for x, so just moving things over. Intercepts here, what would they be? X equals 0 and x equals 1. Yep. Let's see. Trying to work my way down in order of examples here. Stuff like 5 through 12, it says to write a polynomial function of minimum degree in standard form. with real coefficients whose zeros are included in the lists. So, let's look at 8. -4, 1, -I, and 1 plus I. Yes. So, if these are my zeros, how would I set this up? Or what do I know about these? Wait, what'd you say? Okay. What did I say was the thing that everybody was going to forget to do? Yes, that's why I wanted to do this one, okay? So even though I here is by itself, it still has a complex conjugate, okay? And then the same thing over here, okay? It's still going to be x minus 1, but it's going to be plus I in this case. Okay, now this is a lot of multiplying, but how can we make our lives a little easier? No. Okay, calculator is not going to help you here either. Okay, do these two together, go ahead and do these. Okay, so work in groups of 2. Okay, so start with these two, multiply those, multiply these, and just put this up in brackets and then go through and multiply everything together. So these first two, what do I end up with? Okay, so either use parentheses or brackets, either one is fine. How about this middle one? Yeah, well, x squared plus 1. Okay, because this was, I'm just going to make a note here. Okay, this was x squared, or would have been x squared minus I squared. Okay, I squared is -1, so that makes it positive. And then how about over here? What do I have going on here? I would multiply each little piece across, and then we'll simplify everything in a minute. Okay, so you should have something like x squared minus x plus xi minus x plus 1 minus I minus xi plus 1 plus minus I squared. Okay, now that's a lot, right? But we know we're trying to get rid of all the stuff with i's in it, and in theory that should happen. So I'm going to go through and try to cancel out stuff. So I have a positive xi and a negative xi, so I'm going to get rid of that stuff first. I have a negative I and a positive I, so I'm going to get rid of those. I squared, that's -1, so this is going to become +1. So I think that's everything I can cancel. So now I would rewrite everything all nice and neat, just to make your life a little easier. So x squared plus 3x minus 4, x squared plus 1, and then x squared, minus 2x plus 2. Okay, and at this point, I trust that you could continue multiplying this out. Just work on that really quick, and I'm going to try to multiply it out quickly as well and then get the answer because we're running out of time here. So try to finish multiplying that, and then we'll check in, make sure. Y'all having fun with this one yet? Okay, well, this is as far as I got so far. So, anyways, you just need to simplify it down from here. I don't know exactly what it should come out to be. It's not written here clearly, but we'll finish up examples tomorrow. I'll give you some problems for homework that you probably will actually have to do for homework tomorrow. I'll try not to give you too many, though. If you want to start, the problems I'm going to give you from these couple things are just 1 and 11. So if you want to start those tonight to not have to do them, you can.